Okay, for question 34, City designed a ball toss game for her school in the carnival as shown below. Okay, so basically in this question there are 3 targets. So what is supposed to happen is that the person is supposed to throw a ball or something, and then when it hits the target, the bulb next to the target will light up. Okay, so she wanted to set up an electrical circuit in a ball toss game using the following components as such. Now, each bulb XYZ had to be controlled by a separate switch over here found under each target. So this tells me that they have to be arranged in a parallel manner in relation to each other. Okay, so then they said that if either B or C was hit, the switch would close and only the bulb next to it would light up. Okay, so B is here, so Z would light up. C is here, so Y would light up. If A was hit, the switch would close and only bulb up would light up, and the music box would play a victory tune. So this tells me that these 2 components, bulb X together with the music box, they are supposed to be in the same path. So they can be arranged in a series manner for these 2. Okay, so based on the given information, complete the circuit diagram below. So as mentioned, I know that the 3 bulbs needs to be arranged in a parallel manner to each other. So if bulb Z is over here, my Y needs to be somewhere over here, and then my X needs to be here. Okay, so I'm gonna go ahead and fill that in. So I will first draw my bulbs. So this is my Y. Do remember to label it. Okay, and then my X would be here. Reason being that bulb X and the music box should run in series right next to each other. Okay, now then after that, I know that they need to be parallel to each other, so I'm going to draw in the parallel lines. Okay, so now that they are all parallel to each other, X, Y, and Z, the next thing is I need to put the switches in. Now the switches has to be in each individual pathway, so that such that they control them separately. So I'll probably put 1 switch over here and 1 switch over here. Now let's not forget the batteries. So the batteries will also be in parallel to all of them in this case. Make sure you arrange them correctly and the correct number. Okay, so it said that you have 3 batteries, so make sure you have 1, 2, and 3. You have 3 bulbs, 1, 2, and 3. You have 3 switches, 1, 2, and 3. You have a music box, check, and you have wires. So the next thing to do is to check, okay, if the pathway is closed. So from positive to negative, okay, where the switch is closed. Okay, that's good. Next one, Y, and then your Z. Okay. Question 35. Amy bought a facial mask set which consists of a mask screen containing metal-based substance which helped to cleanse her face. She used a handheld mask removal tool with plate X held at a distance from her face to remove the mask as shown. Okay. Based on the information, what could plate X be? So when you think about it, okay, you know that this metal substance is being attracted to this plate X, right? So when you think back on your prior knowledge, what kind of metal substance would actually be attracted to another form of a plate or something? And straight away, what should come to your mind is your metal substance is probably a magnetic material. Okay? So because it's of a magnetic material, your plate X most probably would be a magnet. Now, Amy's friend told her that the metal-based substance added to the mask screen could be made of silver. Do you agree? So we know that in this case, if you already said that the first one, figure out that the first part is a magnet, magnet can only attract certain types of metals, all right, and that's where you recall your knowledge on coins. So C is your copper, sorry, or rather, my mistake, sorry, CO is your cobalt, I is your iron, N is nickel, and S will be steel. Okay. Okay, do you agree with Amy's friend? Why? Okay, so you know that silver is not part of your coins, so therefore your answer should be no. And the reason is silver is a non-magnetic material, and hence it cannot attracted by a magnet. All right. Amy then bought a different handheld mask tool and used the same mask screen of an identical amount of hand surface. She held the new handheld mask remover at the same distance away from her. She observed that it removed less mask from her face within the same period of time. Give a reason. Okay, so probably the most obvious reason, since it is still able to attract, because they say that it is able to remove just less, it signifies that it is less effective. So why could it be less effective? It could mean that there is less magnetic force. So in short, okay, the new removal tool has a magnet plate with a weaker magnetic strength. Now, I also like to stress that whenever you talk about strength of a magnet, you are actually talking about the magnetic strength. So please put in the key term magnetic strength and not just strength alone. 36. Okay. Joe conducted an experiment using the setup as shown below. Okay. From the same starting point on the ramp, he released boxes A, B, and C made of identical materials at one time. Okay, he measured the time given for each of the box to reach the ground. Based on the results above, did the area of contact the ramp affect the amount of friction acting on the box? Explain your answer. This is, if you ask me, this looks like it is a relationship based question. So whenever you have an experiment, the first thing you should do is always to look at what is the change variable. Okay, so now the change variable in this case will be your area of contact, and then after that, the time taken to reach the ground, this over here is actually your measured variable. Okay, so what they're actually asking you is a relationship question whereby how does the change variable affect the measured variable. So remember, there are three possibilities whereby an increase in change variable will increase the measured variable. That's the first one. The second one is an increase in change variable will decrease the measured variable. Or the third one, the change variable has no effect on the measured variable. Okay, so if you take a look at it, my answer to you is, okay, you need, if you're talking about area of contact, you need to first pick the correct experiment to look at. So the two correct experiment to look at would be A and C, because both the mass is actually the same. All right, the only difference is the area of contact. So in this case, I would say that it has no effect, correct? Because when both the mass is at 8, okay, time taken is at, both is at 3, even though both of them is actually of different area of contact. So no, balls A and C have the same mass, but different areas of contact with the ramp. However, they both took the same time to reach the bottom of the ramp. Alright, so it's important to state evidence. Okay, so this is your evidence. Same mass but different areas of contact, same time. So this proves that it doesn't affect it at all. Okay, next. Okay, so the next part over here, snow chains are fitted onto the tires of vehicle during winter as shown as a safety measure while driving on icy roads. Okay, explain how the snow chains act as safety measure while the vehicles are being driven on icy roads. Okay, so for this, right, you need to take a look at this over here. So what this snow chain does is essentially you want to increase friction, right? So between your tires, okay, and the icy snow road. so that there is better grip. It doesn't go off course. So therefore, you can say that this no change increases friction between the tires and the icy road surface, thus preventing the car from going off course or sliding off the road. So essentially, there are two parts. The first part talks about what this no chain does in terms of forces, and the second part tells you what is the effect of it, what's the positive effect, or why do you want to do it. So both of this must be here to get your 2 marks. Question 37. Tony prepared a ball of dough to make a pizza. He took a rolling pin to flatten the dough as shown in the diagram. Okay. State the effect of force exerted by the rolling pin on the ball of dough. So remember, there are a few effects that forces could have. One was to change the direction of a moving object, stop a moving object, and in this case, it's pretty obvious that you are changing the shape, right? So very straightforward. Okay. Now, then Tony tossed the flattened dough into the air and stretched it further to increase its size as shown in the diagram. Draw a line graph in the space below to show the amount of gravitational force acting on the flattened dough as it's being tossed into the air. Now this is actually a very common misconception that I want to take some time to explain. So always remember this, your GPE, which is gravitational potential energy, is affected by two things. One is the mass, and your second is your height, your physical location. Whereas your gravity is only affected by mass on Earth. So can you see that even though he has thrown it higher up, because you're talking about gravity here, okay, height doesn't matter, only mass. The mass did not change at all. So that means the amount of gravitational force acting on the dough remains constant, same, no change at all, even though the height increased. Okay, next part, explain in terms of forces how the flattened dough was able to move up into the air when Tony tossed it. So this is actually a forces conversion kind of question. Okay, so what happens is that in order for it to get up into the air, you have to identify what are the forces that is in play. So the forces that are in play in this case is would be that there is gravity that is actually pulling it down. So for it to go up in the air, Tony needs to exert a push that is greater than your gravity, correct? It needs to be greater such that is able to go against gravity and go up into the air. So how would your answer look like? Tony exerts a pushing force that is greater than the amount okay. Thus, the dough is able to move up.